Good afternoon. Welcome to the Liftoff webinar. My name is Christine Longroy, Senior Director of Ecosystem for Lyft. Happy New Year and thank you for joining us today. I'm thrilled and honored to welcome this Liftoff webinar, Advantages of Customized Tubular Structures, presented by Techreo. Charlie Ritchie, VP of Business Development, will be presenting today. Techreo is a technology-focused company focusing on composite tubular structures, which can be optimized for a number of mechanical properties. During this presentation, please ask any questions in the Q&A chat below, and we will, after Charlie's presentation, be having a questions and answers portion of this. So thanks for joining us today.
Welcome to Liftoff Webinars, brought to you by LIFT, the National Advanced Material Manufacturing Innovation Institute, where we drive American manufacturing into the future through technology and talent development. LIFT is a public-private partnership where we convene and connect government, industry, and academia in the fields of advanced materials, manufacturing processes, systems engineering to enhance America's manufacturing competitiveness, national economy, and national security.
Hi, everybody. Thanks for joining. My name is Charlie Ritchie. I'm a member of the Techreo startup company here in Cincinnati. Just real quick word about Techreo. We are maybe 3-4 years old, and we are taking our significant experience in a handful of industries and bringing new enabling technologies to life. What I'm going to talk today about is one of those technologies, which is proprietary tube structures. We have proprietary tube products and several patents. I'm going to actually update this slide. We're no longer pending. Our first patent was awarded, so we're very excited about that. And what we can bring with this proprietary tube design is breakthrough performance. And I'll get into what that exactly means, but I just want to, for a second, drill down into the graphic down below. The yellow long metal arm you see down below is not our product, but it is exactly where we play. And this is a great example of a long robotic reach that has to move and place heavy items at a long distance. And it has to do that with minimal deflection. It has to do it in a rough environment, and also minimizing ring down time or kind of like or bounce, as I would like to call it, or dampening or improved dampening. That is exactly where Techreo can improve on basically all of those factors. Quick pause is where I think where this helps us play in terms of applications are several places. One is if you have long reach, like thinking about aircraft surfaces, you need to inspect, you need to paint, coat, etc. Maybe paint removal. Also aircraft engines, where you have to reach down inside and with some level of precision hold a sensor or camera still without a lot of bounce, and do inspections on the inside. Also, there's in the world of automation, if you're trying to do grinding, trying to do welding or inspections down a hole or down a long pipe, where it's if you have to do it, and also especially have to do it in an automated way, then we believe the Techreo technology is a good fit. So let me go and step into the kind of overview of the Techreo process. And starting at upper left, you have metal foil, and metal foil really means thin gauge sheet metal. We typically play in the 0.005 inches thick range. That works for us best. And then on the other side, you have performance materials. That could be just as simple as like stainless steel, aluminum, carbon fiber tubes, Inconel, etc. So really any metal, especially that is available, almost always is available at a thin sheet metal form. And what we do then is bring it towards the center of that green triangle of bonding and winding. We use structural adhesive and to bring all of our many years of experience in terms of how to accurately or precisely wind materials. And basically, when you join all those materials up, and you can have different materials at different layers within the pipe or within the tube, you end up with a customized structural tube. What do I mean by customize is you think about if you go around the star there, we have a number of things. So if deflection, axial or torsional is important, if clamping strength is a high requirement, vibration or dampening is important to you, or just need it to be lightweight, we can use the right materials in the right sequences as we wind up from a center, like an inner surface to an outer surface, to optimize for any of those given applications. We just need to know what the needs are, and we can go design against that and I mentioned breakthrough performance. That means well beyond what is currently available in either like metal tubes or steel tubes, aluminum, carbon fiber tubes, etc. I'd like to do one example here. And I guess why start with the zoom in picture? Actually, right here is actually that tube, but a very short version that I carry with me. That has the outer diameter, outer surface is hardened stainless steel. And by hardened, it's for you engineers out there, it's 180,000 PSI yield strength. So very, very tough outer surface, super robust in any environment. Carbon fiber tube is in the middle, which helps with the low deflection. And then aluminum, or we could even do steel. In this case, it's aluminum inner surface. So what you end up with is super high deflection strength, so minimal deflection, excellent vibration damping, lower density than aluminum, and the super tough, outer surface. They do tend to roll, so you gotta be careful with that. Anyways, and you can see the zoom in on the slide here. So hopefully you see the kind of point, but you've got, you have aluminum inner surface, the carbon fiber tube sandwich, call it. And if you look very closely, there are multiple layers of very thin, very hard stainless steel. So another thing that's very important, we believe, to a lot of applications, whether again aircraft, jet engine, or just robotics / automation in general, is damping ratio. So if you move from a spot A to B very quickly, how long does it take as far as dwell time before you get to a solid, a steady point? Our damping ratio is fantastic. We can do 30 times better than an aluminum tube, and 2 to 4 times better than a carbon fiber tube. Again, this leads towards welding, grinding, inspections, robotics, etc. All work. Really will appreciate this benefit. So a little more detail coming up later, a little more data coming up later. Another example here is we can do a lightweight, low density. These are examples, so we can do about anything, but here's an example of a stainless, aluminum stainless sandwich. And this tube would then therefore have like all the strength and of stainless with the lightweight core of aluminum, makes it lightweight or high strength to weight ratio. Also, if you wanted to get a little crazier, you want to go very lightweight, we can take some of those inner layers and make them perforated, where now you're carrying airspace much, much lighter with only a minor reduction in strength. So a lot of creativity is possible with this, and we can optimize towards any application. In this slide, I just really, rather than these are kind of neat photographs, of course, but really the message I want to get, the takeaway from this is the ones you have is stainless, carbon steel, copper, even Inconel. All are various materials we've played with. We've done testing on and done prototypes of. So if there's a material out there that is important, we can incorporate into our product for your application. Some data is always good. So the Techreo tubes are the green and orange ones, and I say other state of the art are the gray and blues. So if you look at tube density, so go over pounds per cubic inch, our green there is better than carbon fiber tube, which is usually thought of as being like among the very best, the best that you can do. Again, let's looking for like axial deflection. Our orange tubes can, again, here lower is better. Our orange tubes are superior to all the competition. So we can do 30% less deflection than a carbon fiber tube. Next one is damping ratio. That's that ring down time I mentioned earlier. And you see aluminum and steel tubes, they kind of sit out there and vibrate like a tuning fork. So those are hard to deal with. Carbon fiber tubes do better, but they are also very, very fragile in an operating environment. One good whack and they kind of break or shatter. And then our design can do 30 times aluminum and 1.7 times the best carbon fiber tube. So we think that's fairly compelling if your application looks for lower ring down time. And almost finished here. So our current capabilities, we can do, as far as outside diameter, we can do anywhere between 2 inches on up to 7 inches. There's just a bigger mandrel in the middle, just drives us to make a larger pipe. So larger pipes are not an issue, larger tubes, not an issue. And lengths, we can do up to 36 inches today. We can do longer if we want to like stitch together various ones through a coupling. But we are no need to worry about that because we are en route to a 72-inch or 6-foot long tubes. We hope by the end of this calendar year here in 2023. Any wall thickness. Again, if you try to buy a tube off from the market, you'll end up with, you get what they make. If you need X more inches or millimeters of thickness, we just do 2, 3, 4 more wraps and we give it to you. So perfectly adaptable, flexible in terms of wall thickness. Then I mentioned the wide range of metals, carbon fiber tubes and other materials. And also we're looking to expand our capability and capacity, scaling up here at the end of 23 and into 2024. Here's, I guess, last slide is this is the principals of Techreo. We've got Kevin McNeil, myself, Thomas Byrne. Here's our contact info. Please reach out to if you have any interest or questions. We would love to have a discussion on what technological or what mechanical properties you'd like to break out of, and we think we'll be able to do that for you. So that's the end of the presentation. At this point, I'd like to pause and see if there are any questions.
Thanks, Charlie. Great presentation, appreciate it. Thank you. So Charlie, we have a couple questions. So I loved how you said, let's get crazy with lightweighting. We know lightweighting is very important to the manufacturing industry. You've talked a lot about applications, right materials, right surfaces. So great job for your team, and appreciate what you shared with us and our attendees. So I'm going to get started with a couple questions. And as a reminder, please, for those folks that haven't added their questions, please go ahead and do so. So are there limitations to what materials can be used, Charlie?
I guess the answer must be like, we're engineers, we're always accurate, right? But yes, but if you look at the choice of metals, for example, you go to a catalog of metals which are available in coil form, and it's I would call a vast catalog. So we've got stainless steels, the copper I showed, Inconel, etc. So really almost any metal that's available in coil form, I think can be drawn down to the roughly 5 mil thickness that we typically wind. And actually I've got on the call here with me, as I mentioned, our president, Kevin McNeil, who's also deep in the technical side. And I can ask Kevin to also chime in on that. So Kevin, if you're out there, maybe you could dive in a little bit into what material options might be, because it's rather than just say vast. I think maybe you could share some specifics.
I mean, yeah, you're right, Charlie. There's the number of metals that are available are nearly the same as what you can buy in sheet metal form. And again, it's just a secondary operation to go draw it down to the reduced thickness that is what is called foil, which is what we use. So again, we've run many carbon steels, many 300 series stainless steels. We've done the Inconel, we've done titanium, we've done copper. I mean, it's just many versions of aluminum. So it's if you've used the material before in any application, we can probably get it in foil form and then incorporate it into our tube structures. So again, I've not ever seen a metal that folks wanted to use that we could not get in foil form. So I think there might be some, but I don't know what they are. So a pretty broad range.
Right. And then we have, of course, carbon fiber tubes is something we've utilized as far as like the inside of our composite sandwich, as well as we can actually do, rather than winding, you can also do tubing if for some reason that makes best sense from a design point of view too. So yeah, thanks, Kevin.
Thank you, Charlie and Kevin. Actually, one of the questions that came in from the audience, and that kind of goes to your tube that you just mentioned, Charlie. Can these tube structures be hydroformed to a shape other than a round?
Oh, we've done oval shapes, right? And that's, I think, feasible, right? And then I'm not sure I would understand specifically hydroform, so maybe I'll pause on that. But then we've tried actually to do like a box shape or a squarish shape, and that gets way harder to do as far as controlling tension and keeping the layers, I guess, in contact with one another so that the structural adhesive can do its job. But like out of round, I think is feasible, but going more with right angles or squares, that gets way harder.
We do, the new machine, Charlie, is designed to do that. We've only tried once previously to do square rectangular. With the new design, the new machine, we think that'll become a little more pragmatic, but we haven't really tried to do that yet. But hydroforming in particular is not, I would say that's not feasible. Once we wind and we use structural adhesive to put the composite layers together, it's a very rigid body, so not a great match for hydroforming. But again, we can change the shape of the mandrel to whatever we want, shape and size. So if there's a different cross-section size or shape that folks are interested in, this really just comes down to selecting the right mandrel size and shape that we start with, and then you'll form that same shape and size as the starting point.
Then wrap on top of it. Yeah, good point. Okay.
Thank you for that. We have another question here. How does the wound up material stay together? Is it welded?
Yeah, good question. And today we use structural adhesive as we wind the different layers onto the mandrel. We apply structural adhesive, and structural adhesive is it's used to hold together aircraft, so it's ubiquitous, strong, and reliable. So it doesn't sound like I don't want it to sound like glue, right? That sounds bad. But so structural adhesive and properly cured is very, very strong. So that's what we do today. We've looked into and have, I would say, line of sight to do welding if applications require it. But so far, as as we've continued to develop, we haven't run into a case where structural adhesive does not work and welding only can work. When we cross that bridge, when we get to that point, then we are confident with fiber laser welding, we can achieve welding if desirable.
Thank you. Any input on that, Kevin? Because I got a couple more questions coming in.
No, that's a good summary. It's usually structural adhesive with the capability to do fiber laser if needed.
All right. Are there conductivity test differences you have measured for your process versus conventional copper tube? Wondering about applications for induction, melting, heating equipment.
I think we've not done that, but that's intriguing.
Yeah, I mean, in general, the structural adhesive we use is a very good insulator. So with that as a bonding agent between layers within the tube's cross structure, we've not tested electrical, but electrical usually follows thermal. And we know we've done a lot of thermal testing, and our tubes have pretty good thermal insulation due to the use of structural adhesive. And we've even done what I call pattern bonding. So you don't have to have structural adhesive everywhere between layers. So you can actually leave in air gaps, which even further optimizes thermal insulation. And I think it would have the same electrical insulation benefits as well. So if you're looking for a great conductor, we're kind of going the wrong direction. But if you're looking for insulation and thermal insulation, both electrical and thermal, we're good at that.
Thanks, Kevin. Another good question coming in here. So thanks, audience, for being on top of this and asking some of these good questions. So how are the tubes joined with other tubes or other parts?
Yeah, so we have tubes we can do what we call like step shaft, so we can have a larger diameter fitting into a smaller diameter. And so as far as what would look like the old car antenna, extending antenna. So that's one way to merge or to combine tubes. Another one is almost like it doesn't sound robust, but it is like a coupling like you see in PVC combining. You can do that and extend the length. And then another one, as far as attaching the tube to a robotic wrist, for example, or to any other structure, is like a flange fitting, and those are ubiquitous out there in McMaster Carr sort of catalog. So they're out there. We can use the structural adhesive to attach to that, and then that attaches via bolt to whatever shape, like a robotic wrist or some other flange. So, any other thoughts for that from you, Kevin?
Yeah, again, it's just we can buy commercial parts, or we can custom design, adapters. So anything you want to bolt our tubes to, like Charlie says, we can design that interface coupling or adapter, and then we just use structural adhesive to bond our tube into that adapter. So tons of flexibility there.
That's great. Thank you. So Charlie, I know you had a couple, you showed, the one tube. I know we show, I don't know if you have the tubes there, show and tell them again. I know there's another question that came in, but I'll ask the question. You can show the tubes if you want for a closer look to that camera, but can the tubes be bent or formed after being wound? Another question from the audience.
I think the answer, Kevin's going to double check me on this one, but I believe the answer is like we have done some initial testing, larger diameters, and then we've taken the tubes through like a bending process. What that exactly does to the structural properties is something we're working out. I think that's the clean most the 10,000 foot view. I'm going to ask Kevin, you can chime in on the 4,000 foot view maybe.
Yeah, I mean, you're right, Charlie. We have done a few bending tests, and it's possible we can bend it. But again, I think the simpler solution is probably just to do an adapter like we just talked about a minute ago, where you can, take a 45-degree coupling or a 90-degree coupling and glue our tubes into that. We have done enough testing. We did, I think, 3 rounds of testing with bending, that there are some options there that we can do. So again, depending on the application, we can pursue bending, or we can just, come up with the right coupling and bending joint and do it that way as well. So both are options.
Thanks. And
I'll tell you, back to just start to interrupt, but just back to the copper and conduction and this question too. If there's any specific application that you're kind of asking, have this idea about an application, and that's led to that question, please contact me based on the info in the webinar, and love to run that to ground for you. So let's have a conversation after this.
Yeah, appreciate that.
Yeah,
looks like the last question coming in is what are the primary applications outside of robotics? You obviously just asked the audience for applications, so you can work with them, but what are some of the primary applications outside of robotics, Charlie?
Oh, yeah, great question. And just start with, first off, generically, like any application that's looking for lightweight, where lightweighting or reducing weight out of a structure is important. That's where we definitely would play. Akin to that is the strength to weight ratio, that kind of thing. And then also anywhere where like you're trying to reduce, again, like the robotic arm, but it doesn't have to be robotics, where damping and basically reducing bounce is important. Okay, I have a little example here. I think it's, for example, here I've got, as far as lightweight, I've got this one. It's aluminum inner core. Then the sandwich meat, call it, is also wound aluminum. And then the outer shell is this super hard stainless steel. So this is ultra lightweight. If this same dimension was all aluminum, we are actually 18% less than aluminum and much, much stronger and better vibration damping and so on. So that's one example. And then if I wish everyone could be in here in person, but one more, and you can't tell by lifting, but this they're looking, it's a 20% less than aluminum, a very small carbon fiber tube wrapped with aluminum, and you can't tell, but this thing is as light as the lightest pen in my drawer. So remarkable advantages in terms of strength to weight. I think getting right now a layer deeper into like where it's lightweight and strength to weight ratios. I know like military vehicle lightweighting roll cages are made of tubes today. Let's look at that as far as some specific applications. I think there's great opportunity there. So and that's all the answer I have, I guess. But
let me jump in on the end of that, Charlie. Last May, we were at the Automate show up in Detroit, and a couple conversations there were things even farther out in left field, I guess I'd call it. Things like a tubular structure that mounts cameras for a vision system. I had somebody talk to me about, hey, we're frustrated today because those are extruded aluminum frames and they bounce like crazy. Charlie mentioned before that aluminum acts kind of like a tuning fork, and they were frustrated that the sensor, the optical sensor, is sitting there vibrating, and they're trying to measure something on a conveyor going by, and it was like inhibiting their accuracy and reliability to pick out defective parts because things are just all bouncing around too much. So this one guy asked me, hey, can you build a structure to support sensors? I'm like, well, yeah, we could do that. We're not really focused on that today, but again, that damping effect where things are just so lively with pure aluminum, it just sits there and vibrates all day, and it just creates all kinds of problems. So that's another example. Another one from get you thinking way outside the box here. A couple of years ago, we were focused on an application where it was more fluid and gas piping. So we were talking to folks that were doing like piping systems for yogurt, where they had this never-ending frustration with condensation on the outside of a refrigerated line running through milk and yogurt and things like that. And again, by building a pipe basically instead of a tube, we were basically putting in enough wound-in insulation that you would never have condensation on the outside. So again, just we can build insulation into the tube in cases where that thermal property is important. And we've done our own thermal testing, and we've seen R values that range from say 5 up to like 25 or even 30 by incorporating things like closed cell foam. We've even done some high-tech versions where we incorporated a layer of aerogel inside the tube structure, things like that. So again, if you've got thermal applications that are where that sort of R value is important to you, we can incorporate things inside the tube wall structure to generate a level of performance that you just can't find without doing external insulation on the outside, which is a never-ending maintenance headache. So in our system, it's totally integrated, zero maintenance going forward.
Thanks for sharing those, Kevin. The kind of out of the box. That's what we like as engineers and manufacturers. We solve problems, and it sounds like Techreo stands ready to help be that solution. One other question: you mentioned Automate in where these conversations where you had. Are you planning to be at any face-to-face events in 24 where folks could come see you? And if so, you could share it. If not, we can share it after this this webinar. So I just thought I'd.
Yes, yeah, we'll be at Automate in Chicago it's May, right, Kevin?
Yeah, the show starts May.
Still way out there for me, but
yeah, May 6th through May 9th.
Yeah, so we have a booth there, and we'd love to set up a conversation ahead of time, but certainly schedule them during that show for anyone who might attend. So
yeah, thanks for that. So that wraps up the questions we have. I'd like to thank both you, Charlie and Kevin. We're thrilled that you are a member of LIFT. We appreciate your membership, your thought leadership, and what you do for the industry. Thank you to all the attendees who joined us today. Happy New Year. Still feel like we can still say that. Look forward to an amazing year. Thanks again, everybody, for joining us. Have a great day, and make sure you stay tuned for the next Liftoff webinar. Thanks, Charlie. Thanks, Kevin.
Thanks for staying.
Bye-bye.
Thank you, everybody. Bye-bye.
Thank you.